3D printing is an amazing technology, but have you ever wondered how you can go from an idea in your head to a real-world 3D printed object? Well, you've come to the right place. My name is Angus, and I've been teaching 3D printing here on YouTube for over 12 years, and I've definitely picked up a trick or two. I've seen the technology evolve from a world of expensive industrial machines kept behind closed doors to nowadays where anyone can pick up a 3D printer for a few $100 and use it right out of the box to make anything they desire. But it can be pretty overwhelming to get started. I get it, I've been there. So I made this, a beginner's guide to 3D printing. This 2-hour video course takes you step by step through the history of 3D printing technologies, how they work, and how you can use them to make amazing things. This is the course to bring you up to speed on 3D printing, and one that I wish existed when I got my first 3D printer all those years ago. Here on Maker's Muse, I am committed to providing valuable educational content in the 3D printing space, and you can go watch a portion of the video course for free right now at the link in the video description below. Or you can stick around here as I guide you through the 3D printing process, how to go from idea to object. Let's get started. You may be wondering, how does the 3D printing process actually work? How do you go from this idea that you have to a physical object that you can hold in your hand and actually use in the real world? Well, it's a few steps, and I'm going to walk you through an example project of me creating this tiny ant-weight combat robot called Pancake. So this is an ant-weight combat robot that we fight here in Australia. It weighs 150 grams, so the size of your palm. Like I showed you an example of another one I'm working on at the moment. They're tiny. They're really, really small. So this is how I created this ant-weight robot called Pancake, and I 3D printed it from a mixture of materials. It's a mixture of TPU, PLA+, and etc. using the FDM/FFF process. Do not worry what those acronyms are. All will be explained in the next section, but suffice to say, it was 3D printed on a low-cost domestic 3D printer, one that I use all the time to make my objects, and it's very affordable, very easy and accessible to get into. And because it's a combat robot, it has a undercutting blade, which is actually made from a metal ruler. So yes, a 3D printed blade probably wouldn't be that good, but it's a low-cost machine, and I thought a little steel ruler would be a fantastic undercutting blade, and it did okay. Now there's 3 steps to go from an idea to a final 3D printed object. First is to create a digital 3D model of your idea. The next step is to turn that digital 3D model you've created into machine code that the 3D printer can understand. This is known as G-code, and we use a program called a slicer to do that, to create the object. And then finally, step 3, you 3D print it using machine or technology of choice and using the material that suits what you're trying to achieve. So let's start with how you actually go about designing it. CAD stands for Computer Aided Design, and it is the creation of digital 3-dimensional models. I used a CAD program to create the digital 3-dimensional model of Pancake, and there are many different programs you can choose from when it comes to creating digital 3-dimensional models. Now these are just 3 I'm going to share with you right now, but there are countless modeling programs out there when it comes to creating objects for 3D printing. So the easiest by far, which we'll go into later in the course, is Autodesk Tinkercad. Tinkercad is fantastic for beginners. It's very simple to and intuitive to pick up, but it's also quite powerful in the way it works. So you can do simple objects all the way down to really complicated ones if you so choose. And it runs on, again, any PC because it runs on the cloud. The CAD program that I personally use is Autodesk Fusion. I've been using it for 8 to 9 years now since it pretty much came out, and it's been getting better and better over the years, but also it's quite expensive unless you have a hobbyist sort of arrangement or you're a student. But if you want to own it as an individual or use it for commercial work, it has a very expensive yearly subscription, which gets more expensive if you want to unlock more powerful advanced features. But the reason I really like Fusion is because it's known as a parametric modeler, which means I can actually go back in time with what's called the timeline to different parts of my design, and I can tweak things. Let's say with this picture here of this little robot with spoked wheels, if I want to change the spokes from 5 spokes to 6, I can go back to the point where I modeled those wheels and then change that feature. And the whole design will update to reflect that. which is really great for that iterative prototyping process that I think 3D printing is fantastic for. It's really good for going back and being able to do that to perfectly hone in on the design I want. But as a result, it's quite a complicated bit of software to learn. Any parametric modeler is actually has quite a steep learning curve. I have a few tutorials on my YouTube channel on learning Autodesk Fusion, and they do have a very good wiki and write-up as well. But again, expect quite a challenging learning experience picking up a program like this, but it can be done, and if you persist, it is incredibly powerful and fantastic for modeling anything with lots of moving parts that intersect with assemblies and that kind of stuff. It's great for my robotics projects, but if you're an artist, for example, who might want to design your own miniatures, it's not the program for you. Instead, you might want something like Blender. What makes Blender special is it's actually completely free and open source, so it will always be free. And there's no overhead of a company trying to control what Blender is. It's the community that controls what Blender is. It originally started out as more of an animation suite, so 3D design, but with an animation goal. But over time, it's branched off into different workflows where you can actually use Blender really, really efficiently to design three-dimensional organic objects with the purpose of 3D printing them. There's actually a sculpting workflow, which I personally find really fun. So it's like working with digital clay. So you have this three-dimensional sphere, and you can pull it, push it, draw on it, make parts inflate, flatten out, that sort of thing. So if you are an artistic type, I am not an artistic type, but if you are, you can use Blender to sculpt incredibly detailed characters, concepts, and then you can go from there and 3D print your design. So I highly recommend checking out Blender if you're into that sort of thing. But again, a bit like Fusion, the learning curve is quite steep. There's some great tutorials out there, like Blender Guru, highly recommended, but I am not an expert in Blender. I definitely wanted to include it because if you're a skilled artist and good at drawing, good at working with your hands, well, you might be great at using Blender. But to create that three-dimensional digital object for 3D printing, you don't actually need to design it as such. You can instead 3D scan real-world objects and bring them into the computer to manipulate and then print that. Like 3D printing, 3D scanning is a very old established technology that's been getting better and better over the years, but I'd say it's lagging 3D printing in terms of its accessibility and ease of use. It's not too bad to scan something. There's even apps on your phone where you can take lots of photos of an object and use a technology called photogrammetry to stitch them together. But in terms of getting something that's accurate and not full of errors, it's a little bit difficult. Now, obviously, this 3D scan an object, you need a 3D scanner. And again, there's apps on your phone that can do it, but to get something that's actually very accurate to the real world and bring it into the digital world, you need a dedicated 3D scanner. And here I'm showing the process of 3D scanning a pineapple. Yes, like the fruit, an actual pineapple. I 3D scanned it using a technology called structured light. And this actually gets a projector and projects these vertical lines, these very, very finely spaced parallel lines onto an object, and it's those distortions as it hits the object, they're read back by a camera. And it uses very complicated maths, which I don't really understand, I'll be completely honest, to then figure out the shape of that object and bring it into the virtual 3D space. But the camera can't see everything, it can't see behind things, almost like a shadow, so you need to make sure you move the object around and get as many angles as possible, and the software will stitch together, but it still won't get everything. There'll be holes where you couldn't scan that area, and that's when it comes to fixing the mesh. So the actual fixing process of 3D scans is very involved. There's automatic ways to do it, but it just guesses. So if there's a void inside and it can't scan inside that void, it'll just close it off with a guesstimate of what the mesh should be to seal up the object and make it watertight, or what's known as manifold, to be 3D printable. And that's where the file repair side of 3D scanning comes in. And it can be really difficult to do and tedious. You need to remove any noise, make sure you're not adding erroneous details or textures. But once you do that, you can then use it to 3D print directly, like a one-for-one copy. And I actually took this scan and modified it and to get this, a Rubik's Cube. So I had this Rubik's Cube like cutter that would turn any object into a Rubik's Cube. I took the 3D scan of the pineapple and I actually made it into parts. You can kind of see here that it's got the parts of the Rubik's Cube. Probably the world's most unsolvable Rubik's Cube, of course, but it was just a fun experiment and a test of a 3D scanner's capability. And yeah, it does have the same textures as the pineapple, which is really, really cool to see. So if you want to create a 3D printed object, you can either 3D design it yourself using CAD or 3D modeling software, or you can 3D scan it. But obviously for my combat robot, I 3D modeled it using Fusion. Once I designed my robot, I wanted to print it. Now we're going to get to the slicing side of things. So this is the program that you use to convert your three-dimensional model into a format that your 3D printer can understand. And it does that by converting 3D data into G-code. This is the machine code with all the coordinates that the machine, the 3D printer, needs to know where to move and when to move and how fast to move to reproduce the object. And it's like literally coordinates, like X, Y, Z coordinates, and every setting that you want to translate from your model into the 3D printer is done within the slicing stage. So for some technologies, that might be how dense the object is. And in that case, what infill does it have? What are the walls made out of? How thick are they? What temperature is it printed at? That kind of thing, that's all set in your slicer. And also within the slicer, you can set your layer height, which means how coarse or fine the final finish of your part will be. Obviously, a coarser layer height will print faster, but it will look less detailed. But a finer layer height may be needed for fine detail, but it takes longer. Again, all of these settings are changed within your slicer before you send it to the printer, but once you're happy with your settings, you send it across and the machine will just follow that G-code. And in this example, I used a FDM/FFF 3D printer. This is the Prusa Mark IV. So this takes a plastic filament and extrudes it out of a hot end. We'll be going more into how this technology works in the next chapter. And it will print the object line by line, layer by layer. And I used a filament known as TPU, or thermoplastic polyurethane. This is actually a flexible filament, which is really, really handy when it comes to the combat robot absorbing impacts. And if you'd like to know how well this robot did absorbing those impacts in actual fights, well, this is my favorite out of the whole competition. Both bots lasted the full 3-minute round, but the big hits did take out Pancake's weapon in the end, so the win went to its opponent, Split. Still, the squishy TPU chassis held up very well to the onslaught of impacts, which was great to see. In the next section, we'll dive deeper into the various 3D printing technologies that you can use to create your designs, from ones you can use in your very own home to advanced metal printing processes that require purpose-built explosion-proof rooms to operate. Well, go on then. Click the link. Go check out the rest of the video course. It is very good. I put a lot of work into it, and I hope it shows. Thanks for watching, guys. Bye.